learning goal today, as it states, is I can graph a quadratic function and describe its domain and range. So let's go back and review what domain and range mean. When I ask you to give me the domain of a function, what am I asking for? If you can't remember that one, maybe remember what a range is, and then that'll help you remember what the domain is. If I say to you, give me the domain of this function, y equals x squared plus 2x plus 1. Anybody remember what I'm asking you for? Why don't you look it up then in your book? Maybe in the back of the book, in the glossary. I bet that's a, oh, that's the word in the back of our book. Go ahead, tell me, feel free to look that up.
Out of all of those coordinates for x values of my function.
Yeah, the set of all the x coordinates or the x values of a function. Well then, what's the range then? The y values. So basically, when we're looking for the domain, we're looking at what are all the possible things x can be. And we're looking for the range values. We're looking for what are all the possible values y can be. We are not going to necessarily be able to list them because there's, how many points do you suppose there are on a parabola? How many points are there on a line? Infinite number of points on a line. How about a parabola? What do you think is going to happen on a parabola? Infinite number on that too, yeah. Infinite number. So we're not going to be able to list them, but we're going to figure out how do we state the domain and the range then. Okay, so one way to get the graph of a quadratic function is we pick the domain values that we want to use. We pick the x values and then we use them to help us find the y values. So we're going to pick a domain value, we're going to put it in, we're going to get the range value that goes with it, we're going to get the y value. So in reality, when you have a quadratic function, kind of like a linear function, you can pick any value you want for x and plug it in, and you should, and nothing should go wrong. Because, tell me, can we square a positive number? Yeah. Can we square 0? Babe, can we square 0? Why not? 0 times 0 is 0. We can square 0. How about a negative number? Can we square a negative number? So if I want you to square negative 2, could we? What is negative 2 times negative 2? No, not square root. Square it. X squared. We're squaring an x value. Can we square a negative number? Yeah, we can. There's really only one thing in math we can't do, and what is that? Well, there's a couple, I'm sorry, not just one. And I think one of them you kind of just alluded to when you talked about square root. Can we take the square root of a negative number? Is there anything times itself that would ever give you a negative number? No, so that's one thing we can't do. But we're not going to do anything with square roots when we're working with quadratic functions. When we're trying to put in values for x, we don't have to take any square roots. And the other thing that you can't do in math is divide by 0. In the quadratic function, y equals ax squared plus bx plus c, are we doing any dividing? Is there any dividing going on there? No. So we, in reality, you can pick any value you want for x. So we say that the domain, remember domain is x values. The domain of a quadratic function will always be this, all real numbers. Because there isn't anything that, if I say to you, I want you to put this x value in and find the y value, that you will not be able to do it. Well, the y value, though, is dependent upon, remember that's the range, what do we get out of it when we put our x value in? The y value is dependent upon the chosen x value. Therefore, the range of the function, remember that's the y value. So since x gets to control the situation, so you know what, doesn't matter if you pick an x value over here on the number line, doesn't matter time you pick an x value way over here in the number line, somehow you will get a y value out of it. But here's the deal. What do we know about a parabola's behavior? What does it do? What does a parabola do? What's its shape again? U-shaped. So what did we talk about yesterday that it does? It opens upward or it opens down. Yeah. What else did we decide about the behavior of a quadratic function? It has a maximum or a minimum. Yeah, it has a minimum y value or it has a maximum y value. In other words, it's never going to go any higher than that y value and it's never going to go any lower than that y value when it opens up. So the y values seem to have kind of a restraint on them. So we are going to say that the range will begin at either the minimum or the maximum. And we will actually write that as an inequality statement. Y can be from here to here. This is what we can do, okay? So use the given table to graph the function, then state the domain and the range. So what I'm going to do for you, because I want you to get good graphs, I want you to get the unit that you're supposed to get. I'm going to pick x values for you, and you're going to put them in and get the y values that go with them, okay? So we're going to, in this first one, y equals, here's our, would you put an arrow by this? We're going to graph y equals 1/2 x squared. Anybody, right now, before we even graph it, can you make any predictions about it? It's going to do what? It's going to open up. Why is it going to open up? Because it has a value that is greater than 0. It has an a value that is greater than 0. It has a positive a value. So we know this one's going to open up. That's much we know. Is this the parent function? Is this the parent of the quadratic family? Y equals 1/2 x squared. What's the parent function? Oh, let's have a little carryover from yesterday. Come on. What's the parent function? I had you get out yesterday's notes. What's the parent function? Abby? So, what is the parent? So that is the parent function? Do you guys agree with her? Is that what our notes say yesterday? The parent function is y equals 1/2 x squared? What did we say it was? Y equals x squared. So a has to be equal to what in the parent function? 1. And the b is equal to 0. And the c is equal to 0. Okay, we got an a value of what in this one? You know what, let's just identify those just for the fun of it here. A equals 1/2, b equals 0, c equals 0. We're not really going to do any, we're not going to use those to help us graph it, but it should give us a little bit of an indication of kind of how it should look. So it's very close to the parent function, but it's not really the parent function. So what we're going to do is we're going to substitute in the x values that I chose for us. So we're going to put 1/2 times -4 squared, and you can't just use a multiplication dot and no parentheses. You can't just use a multiplication dot between that 1/2 and that -4, and then put a squared behind the -4. Why do we have to put it in parentheses? You can have a multiplication dot if you want, but you've got to have those parentheses around the -4. Why? Well, here's the reason. That's apparently you've forgotten. When you take a negative times a negative, you get a positive. I don't know what the graphing calculator does. Let's just see what it does. Would you put -4 without any parentheses in those graphing calculators? So you're treating it just as a regular calculator right now, not as a graphing. Put -4. Remember the negative key is down by the enter key. A 4, no parentheses. Square it. What does it say? -16. Is -4 times -4 -16? No. So those now would you put them in parentheses? Parentheses -4. Parentheses squared. Do it. Parentheses -4. Parentheses squared. What'd you get? 16, yeah, it's positive 16, isn't it? Do we agree with that? Negative 4 times negative 4 is positive 16? So I'm just not going to let you off the hook. If you don't put parentheses around negative numbers when you're taking into a power, you're writing it incorrectly. So next thing we're going to say is, well, we got 1/2 times a positive 16, and half of 16 is 8. So we just now found an ordered pair for our graph. Ordered pair negative 4, positive 8. So that's going to go over under our, go ahead, go put it on your graph. Negative 4, positive 8. Okay. Now we're going to find point number 2. By the way, I will always have you find at least 5 points. So 1/2 has to be multiplied times the x value that has been squared. We square first though, right? We don't take half of negative 2. We square our negative 2, and what do we get? So negative 2 squared is what? Positive 4. Look, I'm asking like a very challenging question. Half of 4 is 2. So what ordered pair do we have? Negative 2, 2. Go ahead and put that one on your graph. Okay, now we're going to use x as, we're going to use 0. Now, in reality, 0 doesn't have a sign, so it doesn't really have to have parentheses. So this is one you could get away with saying 1/2 times with a multiplication dot 0 squared, and it would be okay. 0 squared is 0. Half of 0 is 0. Or 0 times a half. 0 times anything is 0. So we have ordered pair 0, 0. So we're going to go put a point at the origin. Okay, now we have positive 2 for our x value. Now, I'm just going to show you what I'm talking about when I say this is when you can not use parentheses. This is a positive number that's being squared, so we can really write it like that. You cannot do that with a negative number, though. So 2 squared is 4. So 1/2 times 4. Half of 4 is 2. Ordered pair what? 2, 2. Yeah. Ordered pair 2, 2. Oh, I'm starting to see what we call the symmetric behavior going on here. Okay, you do the last one. Get the ordered pair that has an x value of 4. To get a good picture of a quadratic function, what you need is you need the vertex in it, don't you? Where's the vertex at in this one? Which ordered pair is the vertex? 0, 0. Yeah, that's where it turns, and now it has symmetric behavior going on. So we don't draw, like line segments to connect the points. We have a nice smooth curve going through. This is, this could be a little, challenging. So what you do is you just take your pencil and you just try to guide it through your points, making a nice U-shaped graph. It'll oftentimes look like a V. You'll kind of feel like you're not, a very good U maker, but just try to make it as smooth as you can. Is this what we expected it to do? We expected it to open up, didn't we? Yeah. Okay, let's just go put this in our graphing calculator just so we can verify that we have some good ordered pairs, okay? So go to the y equals screen. Whatever's in there, just clear it out if there is anything in there. Here's how we put 1/2 in. Here's how we put a fraction in. I know that 1/2 is a nice decimal, but we need to, what if it's not a nice decimal ever? So let's just learn how to do fractions right away. Parentheses, 1 divided by 2, parentheses, x, and then remember that x squared t to the square root. I want you to do a zoom 6. Do a zoom 6 and it'll take you to the graph. Kind of look like ours. Okay, here's how we're going to check to see if we have the right ordered pairs. The table. The table is the second command on the graph key. So you press the second key and the graph key. Second graph. We're checking our table now. We're checking our ordered pairs. Okay, so we're checking our ordered pairs out. Do we have the right ordered pair? Second graph takes you to the table. Go in the table where you can see where x is equal to -4. Scroll up and down on the table. Everybody needs to be there. Second graph takes you to the table. And we're checking to see, do we have good ordered pairs? So go to where x is equal to -4. Is y equal to 8? Second graph takes you to the table. Thank you. Just have some people, if your x's have some points, you know, like some decimal points in it, does anybody have that where you don't have nice full numbers for your x, or other numbers for your x values? Anybody have that? Okay, so here's, you want to Julia the hands up? Okay, so we're going to go to second window. Press those of you who have decimals going on in yours, we can do second window. And then we're going to go to the second line down where it says delta table. It's got that little triangle table, and we're going to change that to a 1. Just type over it, just say 1. Oh, okay, no. It can't be decimal. So you might have to clear it and type a 1. Okay. And then you can go back, just press your graph key now, and it'll take you back to the graph. If you want to go back to, now go back to your table, second graph. Okay, seriously, you gotta get the, you gotta square this. Okay, press the x squared key right there. So, is everybody in the table now with some nice integer values? Some of your y values might be decimals. I'm talking about your x values. Are your x values integers? Yeah, I want your x values to be integers. Second table. Second, or table, second graph, I'm sorry. Second graph. Okay, you have decimal ones, so do second window. Go down to this line right here. And type and clear that in. And put a 1. No, you're in the wrong one. Clear 1. Type a 1. Now go to second graph again and take you to the table, and your x values should be whole numbers, integer numbers, okay? Okay, did you check out all of our ordered pairs? Are we right? Yes? No? Okay. If you scroll up and down that table, I don't necessarily want you to like scroll forever or anything, but do you think you'll ever have an x value that's not going to be covered? So in other words, when you go, keep going in the negative direction, this kind of just seems to be going on, the x values, and the x values in the positive direction, do they kind of keep going on? So what are we going to say our domain is again? We have to identify the domain. What's our domain? All real numbers. You know what? We could have put an x value in that was like 1.5. We don't have to have integer values. I just want you to have integer values in your table there. You can pick any x value you want. I will try not to make it painful for you and pick things like 5/8. And then you have to square 5/8, and then you have to take that times 1/2. And no. We just pick nice numbers. Domain is all real numbers. Where you go to your notes and write that. All real numbers. Mrs. Legrand chose all the x values for you to do because I wanted you to get a good graph. But in reality, you could choose any values you want for x. But if I let you choose them, guess what you're going to do? You're going to choose probably mostly just like positive numbers because you're like, I want to work with negatives when you don't have to. And then what's going to happen is you're just going to get the arm. One part of your u, you're not going to get the whole u. So that's why I help you by taking values that I know will give you a good picture. Okay, what's the range? It's not all real numbers, that's just a little hint. Look in your y values. What happens? Is there ever a place where you're like, oh, it's never going to do this? It's never what? I think you're right, I just couldn't hear it. 820, okay, but are there any in between? Look at your table, are there any other y values that are not 8 and 2 and 0? Do you ever see a y value that's like, 4 or 4.5 or something like that, or a 5? No. They're all whole numbers? No, I think we have some decimal point answers in our y table too. Here, so what I think is missing in this one, are there any negative y values? Does it ever go below 0? No. Look on your graph. Look right here. Does any of the points on that U, do any of those points have a y value that is negative? No. Remember what it said the range is going to be? We're going to talk about the minimum or the maximum. What does this one have, a minimum or a maximum? It has a minimum. So we're going to say the range is, since it has a minimum, it can't go any lower than that. So it has to be greater than that minimum or equal to that minimum. And our minimum is what? 0. So the range is y is greater than or equal to 0. So not only are you going to graph them today, but you're also going to be able to describe the domain and the range. Little hint, the range is always going to be easy. Okay, let's go to the back side. Use the table to graph the function, then state the domain and the range. Y equals negative x squared plus 1. Trust me, this does not necessarily go so well when the a value is negative because we just can't deal with having negative x's and a negative a. So let's just identify our a value. What is it? Negative 1. What's our b value for this one? 0. There are no x's. C is 1. Okay. We're just going to stay in that practice because now we're going to say, when we're done graphing this, we expect this parabola to do what? Open down. We expect it to open down because it has a negative a value. So when we're done with this, if we don't have a U-shaped graph opening down, we get trouble. Okay, what's this negative sign really mean? It's a what? It's a negative 1. That x squared is actually being multiplied by a negative 1. So why don't we just slip 1 in there? So what we really have here is a negative 1 that's going to get multiplied times the negative 3 squared. And then we add 1 to that. Order of operations. What do we do first? Pardon?
Parentheses.
We do parentheses, but the parentheses this time are just showing multiplication. So do we do the exponent, the squaring first, or do we take negative 1 times negative 3? Should we take the negative 3 and square it first? Yeah, exponents before multiplication. So the next thing we're going to say is we have a negative 1 times what? What's negative 3 squared? 9. And then we still have our plus 1 that's dragging along. Negative 1 times 9 is? That's what we'll do next. Negative 1 times 9 is? Negative 9. And we bring our plus 1 along. Negative 9 plus 1 is? Negative 8. Okay, would you just let's just take a little break here and go into our graphing calculators and just see if we're right. Or we assume that, you know what, we're such know-it-alls. Let's go to the y equals screen. Let's clear out the one that you had in there. Let's just type it the way it is. Negative sign. X. Square it. Plus 1. Where can we go check on this ordered pair at? We forgot to write the ordered pair. The ordered pair is negative 3, negative 8. Where can can we go check on that at, these graphing calculators? In the what? In the what? Where can we go check on this? In the whispers. I wonder who's, why the halls sound like that? The table. Where do we get to the table at? Tori, where do you get the table on the graphing calculator? These graphing calculators can be your best friend. You'll learn how to use them. How do we get to the table? Abby? Second graph. So press the second key, graph key, and it should take you to the table. Will you go in the table and find where x is equal to -3? Go in your table where x is equal to -3. Did we get a good y value? Okay, awesome. We're ready to move on. Go ahead and press the graph key. Does our parabola open down? Good. Okay. We hope that's what happens when we're done with this. Okay, let's go put -3, -8 on your graph if you haven't, and then we'll move on. -3, -8. Okay, we're ready to move to -2. -1 gets multiplied times the -2 squared. Parentheses are critical. Cannot be left off. I will take up points on quizzes for your work that does not have parentheses. So is that a +2 that is getting squared because we take -1 times -2? Or do we take -2 and square it first? -2 and square it first, which is what? 4. -1 times 4 is? -4. Good thing I have good hearing because I can hear your whispers, but I can't believe that's what you're doing. Okay, -4 plus 1 is? -3. So this is quarter. What quarter is this? -2, -3. Okay, you're on your own. Go get the rest of that table. You can find them all and then go graph them, or you can graph them as you get them. It's your call. And once you're done, if you don't want to look up here, you can go to back to your table on your graphing calculator. You can check out all your points there. Look for the x value and see if you got the correct y value. after you have, this time I made you find 7 points. After you have all 7 of your points graphed, you're ready to draw your smooth U-shaped curve with it going beyond the bottom 2 points with arrows at the end to show it goes on forever in that direction. And then I want you to try and state the domain and the range on your own. Try it. And maybe press the graph key too, just to make sure that our graph looks like the graph calculators. We do a good job. State the domain, state the range on your own. We'll go over it, make sure you're right, but I'll just try it on your own. This is what you're doing your homework. State the domain, state the range. Check it out with somebody else, see if you guys agree. Your domain and your range. What's the domain? All real numbers. Like I said, we're not even going to have to think very hard on that one. Even though we only use 7 x values to get the graph, that does not mean there are only those 7 x values in the domain. We can pick any x value we want. I just pick them for you. That's the range. Y is less than or equal to 1. So in other words, this one has a minimum or a maximum? As a maximum. It can't go any higher than that. And the maximum is what? 1. So it can't go any higher than 1. So Y is less than or equal to 1. Good job. Okay. Woo. Any questions on graphing and finding the domain and the range? Hearing none, I'm assuming then you're ready to start on homework. Go ahead and write down what the homework is, and then I'll get you the graph handout that you will use to graph them. And your graphing calculator can be turned off and returned to the suitcase. Those of you who are going to be absent tomorrow, you are in before school with this assignment on Monday morning. This one right here, and the one that I gave you, the worksheet I gave you, is due for class on Monday. There are 4 of them that you have to graph, and then you are doing some other things in this homework also. So you have 2 sets of notes so far to help you. And you have the lesson in the book. If I didn't cover something with you in the notes, you know, I wrote up in the lesson. So I want everybody, after everyone has this, I want you to see what it says about the graphs. Or like 26, so it's the 26 through 29 that you have to do the graphing for. Notice I have chosen x values for your table. So when you set up your table for these problems, look at the graph. I have chosen the x values you already used. So for the first one, I gave you 7 of them, I'm sorry. And the other 3, only 5. But if you get a good picture of the graph, pick the ones that I believe will help us get that. So you put these x values in a table to help you get the y values like we just practiced in the notes. Questions?